एक कटकम
revenue turnover.
Good afternoon, sir.
Good afternoon, class.
Good afternoon, sir.
Good afternoon, sir.
We already saw. Oh, okay. Today people are giving oral, right? Any results yet? Okay, we'll start here. So you guys got to know how to take the push-up distance based on the graph that we saw earlier, that will take the minimum temperature on the bose and maximum temperature on the shaft, and based on when you plot you will come to know the push-up distance. Why we
सर
have to
one
know the
second.
push-up distance? Hanji,
सर
hanji.
सर सर्वेयर ने पूछा था सर ये ग्राफ कहाँ मिलेगा, तो उसको बोला कि ड्राइडॉक के बुकलेट में मिलेगा, तो वो बोला ड्राइडॉक के बुकलेट का नाम क्या है?
नहीं, ये बुकलेट के इसमें नहीं मिलता है सर. दिस इज प्रिपेयर्ड बाय द मैन्युफैक्चरर. ये जो आपका प्रोपेलर जो रहता है उसका, देर आर सम थिंग्स विच आर प्रोवाइडेड बाय द सम मैनुअल्स विच आर प्रोवाइडेड बाय द मेकर, लाइक वो कैसा काम करता है, व्हाट इज द ऑपरेशन, हाउ टू ट्रबल शूट, लाइक दैट. एंड व्हाट आर द some of the line drawings, piping drawings, they are provided by the yard. So this is the one which you will get it from the yard, not from the booklet of dry dock.
So this is
Understand?
from
Have you seen such any of the booklets on your vessel? The one which lists, see, the serial number. This will be the given by the shipbuilding
This
co
is
limited.
given with the manuals only. All the manuals, like
Yeah, all the manuals, but we can't call them as manuals, right? These are the one which are provided by the yard. See here, this is provided by the shipyard. Okay, the manuals with relation to this will be having the operations principle, how it is being operating, troubleshooting, okay, all those things. But here these are the things which are provided by the yard.
तो इसका आंसर सर यार्ड नहीं होगा,
हाँ,
शिपयार्ड
यार्ड
नहीं.
यार्ड ने दिया हुआ है सर. दिस विल बी प्रोवाइडेड बाय, सी, योर लाइटिंग अरेंजमेंट, फिक्सचर्स, पाइपलाइन अरेंजमेंट, and the and this your wirings. Who will give all those things?
शिपयार्ड देता है सर.
हाँ sir. So similarly, these kinds of things are also provided by the shipyard only.
So we can say we will find this graph in this booklet.
Yeah, in the booklet that is being provided by the shipyard.
Okay.
Okay. So what did you answer, sir, about this?
एक फ्रेंड से पूछा था सर, उसने शिपयार्ड का नाम बोला, लेकिन उसने फिर पूछा कि शिपयार्ड की जो बुक है उसका नाम क्या है.
Okay, okay. Some of the things they are provided by the yard only. Okay.
Yes,
So you know Abhi now how to calculate the push-up distance. Push-up distance, as we saw, push-up distance is directly
Can you
proportional to,
repeat the minimum temperature of the boss and maximum temperature of the shafts?
yes sir, yes sir. Minimum temperature on the boss, maximum temperature of the shaft. Why? Because maximum temperature of the shaft, the diameter of the shaft is maximum at that point. Okay, because of the expansions. Minimum temperature on the boss. Why? Because the diameter of the hole, boss hole, is minimum at that point. So we will have to check between the clearances of minimum dia and maximum dia of the shaft. Okay.
Okay, sir.
Not wasting time, and we'll go further. We'll have to quickly finish this, and of course we'll clarify all your doubts. Indrajit Singh had sent me a question: why the tail shaft is tapered 1:100? So we'll answer that also. Okay, observe this. So let's go for fitting and removal. To be specific, now we are talking about keyless propeller. Okay, we don't have key in this propeller and the boss, so this is a keyless propeller. In the keyless propeller, we can use dry method as well as wet method. Wet method, whole of the thing involves two things here in it: dry plus wet. This dry plus wet whole thing is constituent giving wet method. But in dry method, it is only purely dry. We'll see what is dry and what is wet. But for now, just remember that dry methods involves purely dry method. There is no involvement of the W pressure. Whereas in wet method, we make partly we'll use the dry method, and rest among the time means what is the later on whatever the push-up distance is there, that we'll do it by wet method. Okay, so we'll directly go for wet method, since this is the method which is now being used everywhere, and even the surveyors are also agreeing with this method about the explanations of how you fit the propeller. Okay, so this is a manual which is provided by the shipyard. So we are going to see what are the steps that we carry out while fitting it. Okay, so interpretation of the graphs is very important in this. Okay, see what all things you can get from this diagram. I'll slightly zoom it. Okay, this is propeller. Now whenever we say the propeller boss, this is now been bedded with cast iron sleeve. Okay, now this is cast iron sleeve, and this is non-ferrous material of the propeller boss. So whenever we refer the propeller, that means these both are together now. Okay, that is the thing. Now see, whatever this tapered portion is there, this tapered portion is of the shaft, propeller shaft, which is of a ferrous material. Okay, now what is this? I'll change the color. This is the propeller nut. Okay, propeller nut has got the recesses, and after the recesses it has got the rubber. As we apply the pressure behind, what happens? The rubber is pushed outward. So to draw the nut,
Same like pilgrim nut.
yes sir, same pilgrim nut only. Okay, what this is one of the rubber pad. Okay, when I connect the pressure from here, the oil pressure, what happens? The oil will first go fill all the recesses here, and there is a vent valve here. So we'll have to keep the vent open well initially. So when the oil starts coming out from here, what we'll do? We'll close the vent. So now oil is everywhere, which is being pressed up, and the oil is just acting behind the rubber pads. So as I pressurize, what happens? The rubber pads will protrude out. So this will be the position. The rubber pad will be pushed out from this groove. Okay, so what happens? We are using this oil pressure which is acting on this rubber pad, and rubber pad will be pushed outward. So here is the propeller boss which needs to be pushed inward. So when I apply the pressure, the oil pads will move forward and it will start pushing the propeller boss. So propeller boss will start mounting the shaft. Okay, how the arrangement is there?
So,
Can you see this portion of the propeller shaft? This
so
portion of the, हाँ sir.
सर पिलग्रिम नट में तो सर लोडेड रिंग रहता है ना, आगे फॉरवर्ड की तरफ ये जहाँ पे नाइट्राइल रबड़ है वो पुश करता है एक स्टेम को, और वो स्टेम आपका लोडेड रिंग को पुश करता है ना।
Strong steel.
Yes, sir, the loaded ring, the nitrile ring, all the name remains same. But we have to understand it's a ring only, which is 60 degree.
बट सर
Okay,
वो तो
what you
steel
saw
का है।
here, हाँ जी बोलिए।
सर वो तो स्टील का रहता है ना, वो जो लोडेड रिंग रहता है।
It can be steel, sir, but for the uniform application, it can be just the rubber ring also, which is going outward to
And
push
all
it
type
out.
of propeller is fitted with the pilgrim nut.
Yeah, all type. In the wet method, usually we use it. Even in the dry method, this nut remains the same while mounting.
Okay, sir.
Okay. Okay. Whatever this red color thing I have drawn is a propeller shaft. Propeller shaft. See, this portion is the threaded part of the propeller shaft. Okay. On this threaded portion, what we do? We will mount the nut, propeller nut or pilgrim nut. Okay. Now, this is the nut. Okay. So this is and this blue color thing is the propeller, which needs to be mounted over the shaft. Okay, now you see this is the oil pressure which is being given onto the shaft, so that the oil which transfers here on the surface of the shaft and it starts expanding the propeller bores, as well as there is a frictionless surface forming which is in between the shaft and the propeller. Okay, this what we call is W pressure. That is what the meaning of wet. This we call it as W pressure, and this one we call it as the push-up pressure. Okay, so this is a general arrangement to say we have a nut. Nut has got the protruding part, which whenever we supply the pressure from the pump, hydraulic pump, what happens? The nut pushes the propeller inside the shaft, because the nut has got being threaded onto the tail of the propeller shaft, and the only protruding part comes and pushes this inside. So the propeller moves and sits on the propeller. So, and we are providing the wet pressure for the lubrication purpose, as well as it will expand the propeller bores and provides the lubrication, so that coefficient of friction is brought as low as possible, and on applying this pressure it will go and sit at the point. So what is this dial gauge doing here? Dial gauge is mounted, and now on the deflections of the propeller, deflections means as the propeller moves inward, there will be deflection in the dial gauge, so you can precisely know what is the amount of the propeller that is being pushed up. Okay, so let's see how do we prepare for fitting. How do you prepare for fitting? As I said, the dry methods, wet method involves both dry and wet methods. Okay, here I will write in the corner so that it will be a remembrance. Dry method, wet method, what we are doing here, it involves both dry and wet method in it. Okay, now you see this is a arrangement in which in the previous diagram you have seen there was a hydraulic connection which is coming here, and this one we called it as wet pressure. But now that valve is closed and there is no wet pressure that we are providing for the system. This is initially how do we do it? There are problems. Why? Because sometimes the propeller can be fitted properly, or if this is the shaft, and if propeller is being sitting like this, so there will be clearances more at the one side, clearances less at the other side. If the propeller is like this, it should be properly aligned. So how do we properly align it? As it is very heavy, because we are not manually operating it, because there are chain blocks which are having a lot of flexibilities. These things are hung onto the chain block, and we are pushing it inside. So the possibility of this being the center axis of the propeller boss being meeting the center of the propeller shaft is very difficult. Okay, in that case, what we'll do, that's why first we'll use the dry method. In the dry method, what you will come to know? You will come to know whether the propeller boss is properly aligned with the shaft or not. You will come to know. And you will come to know whether the apparatus which is fitted is properly or not, whether the surfaces that are being cleared for a smooth running. That means the surfaces has to be smooth, both on the tail shaft as well as on the inner surface of the propeller boss. All those things has to be taken in consider. First, we'll start fitting it. Then if anybody has any doubts, then please do ask, because it's very important to clarify your doubts. Okay, what we are doing is, now we are not giving any amount of oil in between the shaft and the boss. First, initially what we are doing, we have the hydraulic system. We have a hydraulic system which is going here, and this is the one which has got the pads here to push the propeller inside. And once we start pressurizing up, we'll blow off the air, whatever the air which is there in the system, and as the oil starts coming out, we will block the purge cock. So this is also called as purging with a blow off air. Now what happens, as we start increasing the pressure, similarly like in the hydraulic jacks, what happens, we have this as hydraulic jack. This is threaded portion. Okay, the stud, this is the stud, this is the top of the stud. Okay, and we'll have one oil chamber. Okay, we'll start giving the oil pressure. As we start giving the oil pressure, for initially, whenever you give the oil pressure in the pressure gauge, will you see the deflection directly, or it will take some time to reflect the deflection?
It
will
takes
take time, sir.
It will take time. Why it will take time? Because first the oil has to go fill in all the recesses that is there, and then when the oil, as the liquid is incompressible, and when the pressure starts building up, as and when this portion of the hydraulic jack starts moving up, this is since being threaded onto the stud is also starts being pulled up, and that is the point you can observe that there is a deflection in the pressure gauge, because that pressure is utilized against the tensile stress of this bolt, and the stud or bolt, whatever it is there, that start getting elongated. Okay, same principle will apply here. As and when the oil will start going here, at initial there will not be any pressure rise in the pressure gauge, and as and when we starts pushing it up, starts pushing the propeller, so the clearances, it is like if I draw it little bit taper, you will understand. The system is like this, it is tapered, so the boss is also tapered. Okay, until these tapered portions they meet properly, this tapered portion, whatever, until this tapered portion of the boss comes into action with the tapered portion of the tail shaft, you will not see any increase in the pressure in this. Only when the pushing is complete and there is no further movement possible from the normal pressure of the oil, that time you will start seeing the deflection in the gauge. And that time you have to ascertain that, yes, now the push-up is starting and there is a building up of friction in between the propeller boss as well as the tail shaft. Understood until now?
What is the value of this normal pressure?
Sir, value we'll talk about later, but the procedure you understood now?
Sir, repeat please.
The procedure, like this is a tail shaft. On that, the boss is being mounted. The taper portion of the boss and the taper portion of the propeller are in mating now. So there is no further push-up of the boss is not possible until and unless you increase the oil pressure here. So this is now a initial point where the pressure rise is 0 here, and proper fitting of the boss as well as the shaft is done. Means the axis of the boss and the shaft has to be one while fitting it. That is the only thing. They have to be properly aligned. And now there is no further movement of the propeller boss is possible onto the shaft. Now what will happen? Now you will start seeing that there is a slight increase in the oil pressure here. That is the point you can start knowing that there is a building up of friction starting in between the propeller shaft as well as the boss. Understood?
Yes, sir. Sir, you mean the pressure whatever we are giving, it is going and aligning the hub and the shaft. Then after the pressure will start develop.
Yes, sir. Yes, sir. Because until now, you will not see any pressure here. Why? Because the shaft is when the propeller moves forward, what happens? Whatever the oil you are injecting, that volume of the oil has got a space. Why it has got a space? Because it is pushing these pads forward. So oil pressure will not increase. As and when there is a restriction for the movement of the pads, that time the oil pressure will start increasing. Right or wrong?
Yes, sir. Yes. But there will not be slight deflection not to our what, sir? Slight deflection supposed to have, right, sir? Because it is the oil is which is going and pushing the ring, right, sir, against the propeller weight.
Okay, this is the change in fluids with respect to air. Because what happens, air will first get pressurized, it will draw the strength and then pushes the pads outside. Anything like that. But since liquid is incompressible, what happens? Even though you apply 1 bar, that 1 bar will be sufficient to push these pads outward. And whenever the pads will be restricted from the further motion of the propeller boss, at that time you will start seeing the rise in the liquid pressure.
Okay, sir. Okay.
Okay, for the instant we'll take this as a okay. This is one of the arrangement in that you have liquid here. Okay, as we start pushing it and the liquid is going out from here, so you will not feel any pressure onto this side. Why? Because you are just pushing it, and since liquid is passing out, you will not feel any pressure or you do not any force to push it up. But what happens? The same principle if you consider, now if you close this with a cap and have this liquid, so now the liquid has got restrictions for this flow. At that time you will need more amount of pressure from one end to compress this liquid, and this liquid, if it is having a movement, then again it will not build its pressure, and once if it does not have any pressure, what it will happen, it will break this chamber and come out. That is what we call it as hydraulic pressure or hydraulic hammer, which is used to actuate it. So until and unless you will have the motion for the pads to push the propeller inside, the liquid pressure will not build up, and as and when the there is a restriction, the restriction for the propeller goes over the shaft, at that time it will have the you will see the rise in pressure. Am I clear? Why I'm telling you this, because there is a point in the graph. At that point you will have to understand this. When there is a rise in the pressure, at that time you will understand there is a restriction causing in between the propeller boss and the shaft. All right, let's move forward.
लिक्विड रिंग पे कितना प्रेशर लगा सकते हैं?
Sir, liquid ring पे मतलब this is the ring you are talking about, right?
हाँ, नहीं, अगर ज्यादा लगा दे तो गैप में से वो निकल सकता है ना रिंग, वो बॉस और
no sir, ऐसा नहीं होता है. Okay, in the graph we saw that we are giving a pressure of around, how much maximum pressure we are giving? We are giving a pressure of around 100
ton, 100
100
ton dry
ton
method
in
or
dry method.
yeah,
Okay.
wet 32.
Yes, in dry method, if you are giving able to 100.5 tons per mm, this is the maximum pressure that we are applying there. Yes, so the material is such that if you give this pressure, then it will take. So what is the pressure that you give in the hydraulic jacks? 1200, 1100? Yes or no? That pressure what you give in the hydraulic jacks and all, that does not tell that that is the limitation of the material. That is the limitation of the stud which you are elongating. Following my point?
Yes, sir. Continue, sir.
This is the
In this
stud
method, is there any?
and we have the hydraulic jack. So it's not about the, we give 1200 bar. 1200 bar is the not limitation of the hydraulic jack. It is the limitation of the material of the stud. If we give, we can give 1500 also. In that what happens? The stud will get more elongated and it will go under the plastic deformation. So there is no such limitations for the hydraulic machineries, matlab hydraulic tools. It is a limitation of the part or the machinery that it is working on. As in here, the limitation is the on the stud, not on the hydraulic machinery. Okay.
Sir, in this method of dry method, you will have a marker point up to which you push, or it's the pressure which you denote.
Sir, we are not talking about the dry method now. Now we are only just talking about the alignment of the propeller boss with the shaft.
Yes, sir.
We are talking about that.
But when you come to know when the pressure is increases, you stop, or up to a mark you do this.
Yes. When the pressure is starts increasing, see here, when the earlier you see the dial gauge,
It
at
was
that
zero.
time
Yes, sir.
it is 0, and at some point the dial gauge will start deflecting. Why? Because now there is a restriction for the movement of this. See here, you will not see any of the pads moving out. In this diagram you see there is a gap created in between the groove and the pad starts coming out and it starts pushing the propeller shaft, propeller boss. Get it?
And how will you know whether any dirt is there in between when you're doing this to check, sir?
The first one you have cleaned it. Now you are fitting it.
Yes, sir.
Okay, so based on according to you there is no dirt because you have cleaned it, you have nicely polished it, you have used the acids to clean all those oily things, roughness, grease, everything you have done it. So according to you there is no nothing there. But if there is anything, like when you are fitting, some wind may blow and there can be some dirt coming in, that will come to know when you draw the graph. That is why I'm telling this point of the deflection in the pressure gauge is very, very important. Okay, let's move forward. Very simple it is. Now at this point what you have done, you have applied some amount of the pressure. At that time the pad starts moving up. See, now there is a gap created in between the groove and the pad. that pad starts moving out, and now after some time the propeller bows and the shaft are now well aligned. And what happens, as now you start increasing the hydraulic pressure, it will start reflecting in this. Why? Because it is needs more energy or more force to push this propeller further to mount on the tail shaft, and you will start seeing the deflection also. Now what you will do, you will draw, I'll draw a diagram.
सर एक क्वेश्चन है यहाँ पे सर.
हाँ जी.
सर जो अपना डायल गेज आपने लगा रखा है सर अभी ये
हम्म.
जो अलाइनमेंट करते हैं उस पॉइंट पे भी ये जो अलाइनमेंट डायल गेज रीडिंग शो करेगा वो काउंट करेंगे नहीं करेंगे?
अभी अभी जब अलाइनमेंट करते वक्त उसका जो रीडिंग है सर उसको जीरो कर देना का वापस. दैट इज नॉट
ओके
बीइंग काउंटेड.
ओके सर.
Okay, let me draw the diagrams with the different color. You'll understand. This is tail shaft. Now okay, this is propeller shaft. Okay, you have mounted the nut on this. Let me extend this. Nut, and nut has got the pads to push forward, is fitted here, and hydraulic pump. Okay, now what you did, the tapered portion of the shaft is meeting the tapered portion of the boss. Okay, and there is a nut which is to push it. Now what happens, as long as you start applying pressure, now there is a point when you need to apply more force. Why? Because the touching or the proper alignment of the shaft with respect to boss is now done. Everybody understood until now? Everybody
Yes.
understood until now? Okay.
Yes,
Now
sir.
what happens? Even a slight increase in the pressure will now start pushing the propeller inward. Now what I will do? I will draw a mark from this point to the push-up distance. Say me one push-up distance. Any distance, tell me.
25 mm.
Okay, 25 mm, which is too much, but okay. Let's take it as 25 mm. So from this point, I will mark a 25 mm, and from that next point, I'll mark another 25 mm. Okay. Why I mark this 25 mm and I start pushing it up, and suppose it stops at this point. So from this point to this point, what is the distance? Suppose I'll start pushing it up and it will go until 15 mm and it will stop. So there is a 10 mm left between this point and this point.
Yes sir.
So we'll come to know that it has been moved 15 mm. So now suppose when we push it, it has moved 26 mm. So how will you come to know that it has moved 26 mm? Because once
Your
this point is covered under this, you'll not come to know how much it has been extended from this point. That's why we are taking another mark which is at further 25 mm, so that after this 25 mm is completely covered, hence we can calculate the distance which is left after here. So that is the reason why we mark 25 mm first and then another 25 mm. Understood?
yes sir.
And the dial gauge is mounted at this point. Now, as and when this is there, now what I will do, I'll slightly give some pressure.
Sir, one
सर वो थोड़ा सा अनक्लियर था what आपने जो पूछा.
सर ये पुशअप है ये
यार साउंड नहीं आ रहा यार, क्या
कमेंट सेक्शन में डाल दो,
चैट में डाल दो, चैट में डाल दो।
चैट में
Yes,
डाल
please put this up
आवाज
in the
नहीं आ
chat.
रही है इसकी।
Yeah. Okay. So what did we do? We have marked up a point at 25 mm and we have marked up another point at 25 mm. Now what you do? You give a pressure here, say around 20 bar pressure is applied on that, and you will further see some movement on the propeller shaft, and you will see there is a deflection in the dial gauge. Okay, let's plot a graph now. If everybody understood this situation, dry fitting, wet fitting, this both things involves the wet fitting. It is only wet fitting we are studying today, so don't confuse this with the dry fitting. Okay, what we are doing is now we have a reference mark. What is y-axis? A push-up pressure. Okay, and we have the x as the push-up distance. A point is the point what I say now when the both the things meet, I will give a initial pressure of 20 bar and I will see what is the push-up pressure, and this is 20 bar now push-up pressure, and what is the push-up distance? That distance I will take it as 0. That is what you saw in the previous diagram. Now what I will do, I will start increasing the pressure, say every 20 bar I will start increasing the pressure and I will come to know what is the push-up distance. Okay, I'll first increase the pressure by 20 bar and I will see there is an increase in push-up distance. This is the push-up pressure, push-up distance. Okay, next I'll increase another 20 bar and I'll see what is the push-up distance. Next 20 bar I'll increase again. Next 20 bar I will increase again. Next 20 bar I will increase again. So what I'm getting here is a linear curve. Okay, we are getting a linear curve. That means the push-up, if you are increasing push-ups by 20 20 20 or anything, it's like 50 50 50 you increase, or 25 25 25 you increase, anything with the equal interval of time. When I increase the push-up distance, what I'm getting, I am getting that propeller is moving in a straight line. That means I'm getting a graph which is plotted in a straight line. That means the pressure what we give is directly proportional to push-up distance that is moving. Okay, now you see how do we come to know that there is a dirt or dust in the system? Just observe these three graphs. Okay, for the push-up distance what I gave, at equal intervals, now there is equal movement of the push-up of the propeller boss is taking place. That means this thing will tell us that the, as shown in the diagram, it is acceptable to have a line nearly straight even though a slight irregularity in marked points is existed. That means this is the system what we can take it as. Now the system is properly fitted. So what did we do in the dry method? In the dry method, whatever we used for the pushing up of this, we are only knowing whether the material, whether the tool is fitted properly or not, whether the surface of the tail shaft and the propeller boss is means it is free of dust, free of dirt, anything like that, or the improper tool or the irregularity in the machinery. One thing we saw human errors, one thing we saw the cleanliness, one thing we saw the apparatus errors. from dry. Till now we have not applied any of the pressure in the W side. W side in the sense the pressure in between the boss and the shaft. This is dry method. We have applied only the pressure we have applied. We have seen how much is the push-up pressure and how much is the reaction of push pressure with respect to push-up distance. Okay. Second thing, let's see second graph. Let's study the second graph now. This is again the push-up pressure. This is the push-up distance. I have increased the pressure. Okay. I have increased the pressure, say 20 bar, and this is the push-up distance I got. Next, again, I will increase it for 24 bar, and where I am getting the push-up distance less. Now again, I increase the pressure, the push-up distance, what I am getting is here. But according to this graph, what is that? This is the pressure given. So this is the distance. Next, to move the same distance, they have given double the pressure. Next, again, the irregularities is there. And if you find such case, what happens? In this, there is a probable graph that we draw. The average of these 2 points, if you take, and if you still draw the line, you will have that the line is a linear line. That means in this, what is there? Line is showing that it is the apparatus needs correction. That adjusting apparatus for correction as extensive irregular might be caused by inferior defect of apparatus. That means if you're getting such a graph, that means the apparatus is problem. First thing you saw the human error. Second thing you saw the apparatus error. Now third thing, you should get the linear, but
Sir,
you are getting a line which is exponentially. Yes, sir.
Sir, this apparatus means the pressure got from the hand pump, that is faulty, sir.
Yes, sir. That is faulty.
Okay.
Okay.
Okay, sir.
Okay. Next thing, see how the apparatus may go wrong. Hydraulic pump is there. For every stroke, it has to pump in 50 grams of oil. But since because of the loose o-rings or anything, for one push-up, it is giving 50 grams of oil. Next, it is giving 45 grams of oil. So what happens? There is the irregularity created in these strokes. So those strokes will cause the irregularity in the push-up distance also. Finding my point?
Yes, sir.
Okay. Next thing, what is there? Here, same thing again, the push-up pressure, the push-up distance. I will increase a pressure of 20 bar and I will see this is the distance. Now again I can increase the pressure. What happens? It has for 20 bar it has moved, let's say it has moved 20 mm. Next for next 20 bar it should move 20 mm only. Yes or no? In this case it is moving 20 mm only. But in this case what is there? It is moving 18 mm. In next 20 bar when I increase it is moving 15 mm. In next 20 bar when I increase it is moving only 10 mm. The distance between this is less than the distance between this, is less than the distance between this, and is less than the distance between this. That is why you are having a curve which is rising exponentially. If you talk about this, then this will be the curve of the nature of what? A is equal to B square. Anything which is exponentially, it will be increasing. That will be the nature of the curve. Like in the pump curve, if you have observed that the power of the pump is directly proportional to n square. So in that, the curve will be exponentially like this. Understood? So if the curve is like this, then what is holding it from moving forward? You understood that last graph? I want to draw the last graph again. Okay, linear graph, the push-up distance, is same as that of the movement. If you are giving 20, it will move 20. If you are giving 40, it will move again 20, 20, 20, 20. But if the graph is going like this, curve, first it has moved 20, next it is moving less than 20, and after that it is moving less than 20. Understanding point, whereas the pressure is again remains the same, 20, 20, 20, whereas the distance it has moved has reduced, distance it has moved has reduced further. If this is there, that means there is some hindrance that is offering in between the propeller boss and the tail shaft, what it might be. Now that is the point
Not
you will
smooth.
come to know. Yes, sir.
Maybe it's not smooth. The surface is not smooth.
Yes, yes, I wanted this from you. The surface is not smooth. There is some dust or dirt which is restricting for the motion of this propeller boss over the tail shaft. Understanding? So that is what
Yes,
I
sir.
wanted to tell you. See here, when the line is not straight as shown in the diagram, please check the contacting surface of the tapered part as some dust and others stuck to surface. This is the thing. Okay. After that, please start again and the operation from the beginning. Understand? Are you able to get what are the three graphs that's showing here?
Yes, sir. Yes, sir. Very easy.
Okay.
Sir,
Now,
now we have not started inserting the oil in W side, sir. Only dry side we have started.
yes, sir. Yes, sir. Only W side. Only W side. First, we have to know whether our system is proper, whether it is improper, or whether apparatus is improper, or whether the surface preparation is improper. Once, if you know, if you are obtaining this type of graph, that means there is a linear motion of the push-up distance as there is a linear pressure given. So once if you are at this point, that time you'll come to know that everything is proper, and that time you can start giving the W pressure and reduce the push-up distance. Reduce the pressure required to push up in.
Will
Sir,
reduce
now,
frictional.
consider now we have to push up to 20 mm, sir. From the graph, we got 20 mm. We have to push up. Up to what distance we use this method and we go for the W method, sir?
Partly, sir. Partly, maybe 1/3 you will start pushing it up with the dry method, and remaining 2/3 you will do it by. This is 1/3. The distance you will do it by dry fitting. Remaining 2/3 you will do it by wet fitting. So let's take for the ease of calculation, if you have to do 24 mm push-up distance, 8 mm you will do it by dry and 16 mm you will do it by wet, or
Sir, one doubt, sir. Why
1/5
it
you
is
can do
called
it from
W
here,
method?
4/5 you can do it from here.
Yes, sir.
One small doubt. Why it is called W, sir? W method. Could not be.
Sir आते सर हम लोग आते हैं. W is wet.
Okay, W is weight. Okay,
W is wet.
okay.
Sir, the standard point is mark on propeller, right?
Standard point.
हाँ.
नहीं सर, स्टैंडर्ड पॉइंट को हम आएंगे सर अभी. First thing what I wanted to tell you is I wanted you to understand this nature of the graph and how do we know that whether have we fitted the instrument properly or not.
Sir,
See
can
here
you please type
the
graph, sir? Graph once again, sir, because we have point 1 on the top and below the line, sir. How it is coming?
here.
Yes, that graph.
Okay. Push up pressure. This is distance. This is pressure. Okay. First we have given some pressure and it is at 0. That means like we have given some pressure and it has not shown any deflection. After when certain pressure starts increasing, it will start showing the deflection because we need more force now to push it up. Okay, at 20, let's take 50 bar. We have given 50 bar and it had shown no deflection, but yes, the 0 push-up distance. Now again, you will give now 50 bar more. Okay, next you will give 50 bar. So this is the 50 bar you will give. And what is the distance it is moved? it has moved a distance of say 30 mm. In the first 50, it has moved 0. First 50, it has moved 0. Next 50, it has moved 30 mm. Next 50, it has moved 10 mm. Next 50, it has moved 50 mm. And next 50, it has moved 80 mm. Is this the irregularity of the graph? So next we'll plot the same thing here. For the first 50, it is at 0, 0. Next 50, it is at 30. So 30 from there, 30 from here, will be somewhere here. For the next 50, it has moved only 10. That means 30, 10. It will be somewhere here. For the next 50, it has moved 50. The next 50, it has moved from here 10, 20, 30, 40, 50. And for the next 50, it has moved 80. 50, it has moved from this point 80 is somewhere here. So what is this? It's a irregular of the graph. In this irregular of the graph, what they will do? They will take mean point from this. They will take mean point from this, and they will draw a line. That is what you have: a point here, point here, point here, point here. Mean point of this, mean point of this, they'll start meeting. That is how you will have a nature of graph, but the graph is imperfect. Followed?
Followed, sir. Sir, this 50 plus 50 plus 50 we go right, sir. The bar.
Yes, sir. Yes, sir. Yes, sir. 50 plus 50 plus 50 plus 50. Okay.
Got it, sir. Got it.
Okay. Now I'll explain you how do we plot this graph here. Okay. Here I have a open space. What is this? Y-axis is a push-up pressure. On the x-axis we have push-up distance. Okay. Initially what I said, you will have a point. At that point you will increase, say suppose you have given a 50 bar and the point is 0. That is the initial point where you have the deflection. Next you will start increasing 50 bar, 50 bar, 50 bar. You will do it for some 6 points: 1, 2, 3, 4, 5, 6. Now at this point is there. Next you will increase 50 and you will see the uniformity. Let's consider that no human errors. The dirt is also free. The system is free of the dirt. The friction is reduced. Now you are only concentrating about how much push-up distance and how much it is going. So you will have to find out this. Now for next, it will go 10 mm, 10 mm, 10 mm, 10 mm and 10 mm. Okay. So the graph is linear. 1, 2, 3, 4, 5, 6. Okay, at this point, I'll draw a line. Now what I will do, I will start applying the W pressure and similarly start increasing the pressure from 50. So what you will see, now suppose at this point 50, 100, 150, 200, 250, 300. At 300 bar, if you look in from the, if you remember from the graph, for 1 mm, you need to have 100.5 100.5 tons for 1 mm in dry method. Do you remember?
Yes, sir.
Okay, now at 300, so how much distance you might have moved according to that graph? 3 mm?
Yes, sir. 3 mm.
Yes.
According to this, it is 3 mm. Now, the same thing, if you look at the thing in a wet, it is like 32.5 tons you require per 1 mm. So if you look at 32 and 300, so by this time you should be able to move 10 mm approx.
Yes, sir.
Yes, sir.
Following, for if you are looking in the dry method, you need 100.5 tons for 1 mm. So when you reach a 300 ton, that means you have moved roughly 3 mm. Similar thing, if you look at the wet point, you need 32.5 tons for 1 mm, but you already have 300 pressure applied. So it is means that means you have already traveled 10 mm of distance. So this particular point, when I draw it down, so what happens for every 50, now it will start showing more amount of push-up distance as before. So for 50, if you apply, it is showing 10. For the next 50, when you apply, it will start showing you more than that. Maybe it will start showing you 30, 35, 40, like that. So every time it will be increasing. Okay, so that you will have a more flatter curve when you have less pressure and more push-up distance. So one curve is, the slope of the curve is more, here the slope of the curve is less. So when I extend this both curves backward, the both curves will start meeting at a point. Of course, both curves, the curve does not meet here. The both curves will, this is the curve. The both curves, when I extend behind, what happens? It will start meeting at a point. So this point, we call it as B, and this is the standard point. Now, what is the significance of finding a standard point? So you understood how we obtained the standard point?
Yes, sir.
Okay, now what is significance of this standard point? Why do we have to know the standard point? Because initially you have given some pressure and you notice that there is no deflection in the dial gauge. Why? Because the propeller has not moved. But the propeller has not moved, but the propeller is staying at the same point, but there is some amount of pressure, friction build up in that. That friction is equivalent to this push-up distance, what is there in the graph. You understand?
Sir, repeat again, sir.
Okay. Initially, I have told you, without the rise, what happens? You are given a 50 bar pressure. 50 bar pressure. It was, if there was a gap, then it would have moved 10 mm for you, like this. But this 50 bar pressure, that time you adjust the dial gauge to 0, saying that you took that as an initial point. That means the 50 bar what you have given initially is now gone waste. Yes or no?
सर वेट का कुछ नहीं होता, वेट है इसके लिए मोमेंट 0 है.
No, actually.
हाँ सर, वेट है उसके लिए 0 है, बट जो भी वेट है थोड़ा तो मूव होना चाहिए था ना इसको.
Yes,
But
yes, sir.
first 50 mm I have considered it as 0. That means this 50 mm is not going waste. What it has done, it has taken it from this distance. That distance is now what in the dial gauge we'll making it 0, so that we'll have a standard point. And on that we are not making any mistakes. Like it's the same thing. When you fit the dial gauge in the web, what do? You fit it at the 0, or you fit it first and then adjust it to 0, right?
Yes, sir.
Suppose the web's distance is say 30 mm. So what will be the dial gauge, total dial gauge you will have? You will have it somewhere around 35 mm, right? 5 mm you will compress it and then you will adjust it to 0, so that even if it goes on the negative side, you need some marks. Even if you go on the positive side, you need some deflection, right or wrong?
Yes.
That thing
Right.
what we are considering is here. So I give first 50 bar pressure. I'll take it as that 50 bar is now, I don't know how much I have pushed it. but I have pushed it little. How much? That I'll only come to know when I extend it backward. So this will be my total push-up distance. That thing you'll see in the graph.
Since what is the significance? You told no initially. Significance sir okay clear, but significance में क्या बोलेंगे?
सिग्निफिकेंस में यही बोलता है, यही बोलना है कि आपको फर्स्ट 50 बार आपने दिया और आपने एडजस्ट कर दिया उसको 0 पे. हाउ मच यू हैव पुश्ड इट, हु नोज. That how much you have pushed it, that you will only come to know when you extend it backward and when it moves onto the, when it meets onto the x-axis.
But sir, actually it has not moved.
प्रोपेलर पे कैसे मार्क करेंगे स्टैंडर्ड पॉइंट को सर?
हाँ जी,
प्रोपेलर पे कैसे मार्क करेंगे स्टैंडर्ड पॉइंट?
अब प्रोपेलर पे मार्क करने की जरूरत नहीं है. When you extend it, after this whatever you get it, like this here, the actual push-up distance, that you will come to know. But for the theoretical push-up distance is only
this
from.
point we will draw on the graph only. No?
Yes,
Nothing
sir.
yet.
Yes, sir. This is the theoretical push-up distance. What you are getting from the
Okay,
graph,
sir.
you got this. You have took a point from here, and you have increased the pressure until you find a the push-up distance. That means, say from the graph, you are getting the push-up distance of 20 mm. This is the 20 mm is theoretical push-up distance what you got. But actual push-up distance, the practical push-up distance is will be slightly more than the what you get it from the graph.
So that means the point B is just a virtual point.
It's a virtual point, but earlier initially 50 bar you have given and you
Yes.
adjusted the dial gauge to 0.
0.
Okay, so the dial gauge might have already shown a deflection of 10, it might have shown a deflection of 15, 20, but what you are doing, you are making it a 0. So you don't know what the dial gauge has made the deflection.
Sir, when we initially applied 50 bar pressure, that time propeller moves or not? I'm not asking that we either whether we set it on 0 or not.
Course move, yeah.
Okay, you have given a 50 bar. So to move 1 mm, how much you have to give? 100.5. Yes or no?
Yes, sir.
Okay. Similarly, if to move 1 mm, I'll have to give 1000 tons. When I move 50 tons, so what will be the deflection? 20th times of the, not 20, yeah, 20th times of the 1 centimeter, right?
Okay.
Yes, yes.
20th times of the 1 centimeter, which is very, very hard to calculate. That is the thing. What we do to maximize the readings, we'll first take it as one pressure, we'll make it as 0, and then we'll start calibrating it. Afterwards, when we extend it back, what we get is the initially how much you have stopped it. That is the thing you are going to get. Suppose we need more force to push it up, but we are applying only less force so that we have particular point on it.
Okay, sir.
तो शाफ्ट पे कहाँ से कैलकुलेट करेंगे? शाफ्ट पे डिस्टेंस कहाँ से कैलकुलेट करेंगे?
Shaft पे, that's why I told the 225 marks और जो मैंने draw किया था, have you followed?
Sir, actually, does it happen like when we are pushing up? Is it moving to the standard B point in the practical?
The standard B point is only the practical thing what you have, sir. So from the theory, we are getting 20. We are pushing only 20. But what will happen? You are pushing more than 20 when you take it the standard point. Okay.
Actually, sir, initially movement नहीं initially movement काफी कम है ना, बहुत minor है, इसके वजह से हम लोग उसको 0 पे सेट कर देते हैं. Just for the age of calculation, right, sir?
Yes, sir. Yes, sir. For the calculation purpose.
Sir, you mean after we keep the dial gauge setting 0, then only we start marking how many mm it's supposed to move. So this
yes, sir, yes, sir,
point
yes,
is
sir.
neglected only. Just for theory we are calculating.
Yes, sir. Yes, sir. Yes, sir. Okay, see here.
सर लेकिन हमने एग्जाम्पल तो 25 mm लिया था ना।
हाँ 25 mm सर वो एग्जाम्पल लिया था हम लोग सर. See here, fitting operation, you will understand it by here. The temperatures on the boss CB, the propeller shaft CS at several point opposite every temperature. If the temperature of each point has a large difference, the lowest temperature on the propeller boss and the highest temperature on the shaft are used. इतना clear हो गया? Next. Refer to figure dry fitting. So in the dry fitting, what we are doing? Okay, for reference, push-up load is set to 190 to 490 kilonewton. So here you see here, read this line. After the oil pressure is stabilized, what do you mean by the oil pressure is stabilized?
There is no
Initial deflection.
No fluctuations.
No fluctuations. When will have no fluctuations?
So when there will be complete oil inside.
Whenever no air already
When the
pushed up.
restriction starts. When there is
When you will have no fluctuations in the pressure gauge?
When there is no movement of the propeller boss further.
Yes. No. When there is no movement of the propeller boss further, what happens? That time the deflection has to start. Understanding? That's why I told you that point was very important. This is the propeller boss. This is the propeller boss which is being mounted onto the shaft. Whenever you start pushing it, there will be movement of the propeller boss. That means the oil pressure will start fluctuating. It will not be constant. Okay, oil pressure will only stabilize when the complete push-up of the propeller boss is done on the shaft and there is no further push-up possible if you increase little pressure. To the push-up possible, you have to increase more pressure. That is what I was referring.
But
So
sir,
when
then
there is a
how
restriction for
are
the
we, when there is no fluctuation in the pressure, so then how we are plotting the graph between like push-up pressure versus push-up distance?
Sir, see here they are not talking about the fluctuation. They are talking about after oil pressure is stabilized. What do you mean by the oil pressure is stabilized? Okay, I'll explain again one more time. So this is a tapered portion. So when the tapered portion, another tapered portion enters it. This is a tapered portion. Another tapered portion enters it. This is another tapered portion. Okay. Was. When this part touches this part and starts moving up. Suppose when it is touching at this point, there is sufficient gap created at this. It will be something like that. Whereas top portion is touching, the bottom portion has got some gap. Again, you start pushing it up, and at one point, what happens? The proper alignment of this boss and this shaft takes place. समझ रहे आप?
सर और ये वाला पॉइंट जो है जिसमें दोनों प्रॉपर
that
अलाइनमेंट हो
means
गया ये
after
पॉइंट बी है.
Okay, let's take a normal spool and the piston. A piston here, and here there is hydraulic. It is open-ended. When you push it, here there is a pressure gauge. Will the pressure gauge show any deflection?
No.
Okay, I will make this little bit narrow. Will the pressure gauge gauge show deflection?
Yes.
Yes.
Yes, it will first increase, and then as long as the oil or water which is flushing out through the hole, the pressure gauge will again drop. Now what I will do, I will make this hole further narrow. Will the pressure gauge deflect?
Yes, sir.
Yes, initially it will again increase, and as the oil escapes, it will be 0. Now when I close it completely, what happens? As long as I push it, it will start increasing its pressure. The pressure in the inside, the cylinder will start increasing. Similarly, imagine that this is a point where there is a cylinder and we are applying a pressure. The cylinder has to move forward. So it will start pushing this, and it will start pushing this pad forward. And now what will see? You will see that the pressure will start increasing now. Yes or no? So even if you stop pumping here, the pressure has to hold at that point. Yes or no? In the hydraulic jack, what you do? Can you
Yes,
stop
sir.
the hydraulic jack at 300 bar? Can you increase particular pressure on the hydraulic jack and you can stop there, right?
Yes, sir. Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
So how the pressure is able to stay there? Because of the, so I will increase the pressure here, say around 300 bar, and I will stop there. The pressure will not reduce, pressure will stay at 300 bar only. But if the elongation is not met completely, still the oil has got some space to go and occupy. As long as we starts giving stroke, it will still show us 0. Yes or no?
Yes, sir.
Yes, sir.
Once the
Understood, sir.
stud starts getting elongation, at that time there will be a increase in the pressure, because it is the pressure which is acting that has to overcome the strength of the stud to elongate it. Similarly, the pressure here when exceeds the strength of the propeller boss, that time only the propeller boss will start moving up. Until now, what will happen? Only there will be some increase in the pressure, whereas the propeller boss has just adjusted its surface of the tapered surface over the surface of the tail shaft. Followed now?
Yes, so that means the pressure will not be shown on the pressure gauge until it touches the.
Yes, sir, that's what I am telling. Until these pads go and touch the propeller boss, there will not be any deflection in the pressure gauge here. Once there is a restriction for the movement of these pads from the propeller, and that is the point where the pressure will start building up. So you can't take it as a 0 only. So even if you don't want to take 50, let's consider a small pressure of 10 bar, which is sufficient enough to at least the pads has to move out and hold the propeller in place. That is the what meaning of stabilizing. Okay, we'll read further.
So
You may understand it.
that means if we are
Sir.
reaching up to the 50 bar pressure, then
Mhm.
we'll wait for some time and it will reduce the pressure for let's see up to 40 bar it is now. Then we
Yes,
have
sir.
further
You'll have to see whether the pressure is reducing or pressure is maintaining.
Sir, in simple word, we can say this is a holding pressure because
Yeah,
it
holding
already
pressure. In
it
simple
is
words, you
already
can say
touched.
this is a
It is
holding
not
pressure.
allowed to fall back, and it is not moving forward. It is staying there only.
Yes, sir. Yes, sir. Yes, sir. That is the simple. Okay. So see here, let's read out here. After the oil pressure is stabilized, set dial gauge at 0. Now why you are setting it as 0? Yes, you have given some pressure. There is no movement from the propeller. That is the point where you see the stabilizing. And now any further you give pressure, what will happen? The pressure will start rising up and the propeller will start moving inward. This is now at the starting point. Okay. Now The relation of the push-up distance and the push-up pressure to the fitting records it, A point in figure 4. After that, increase D pressure. D pressure is the pressure which is given to the nut to push the propeller inward. About 5 MPa. 5 MPa is 50 bar. Okay. Read dial gauge and record the data after the oil pressure is stabilized. Means again, you are given some stroke and you have to wait for until the deflection in the pressure gauge has to meet at a point. Initially, it may rise, then fall back, or it may slowly rise to a particular point, or it may rise and fall back. That means there is some leaks. Followed?
Yes, sir.
Now, minimum 5 points of reading with repeated same increase in the D pressure to be recorded. Minimum 5 points. Okay. See, as I said, for reference, it will reach to 1/5 of the target distance of the propeller fitting. That means in the dry fitting, you are insert the distance. Suppose in the 20 distance, if you want to insert the 20 distance in the dry fitting, you will go it for 1/5. That means 1/5 of the 20 is 4 mm here, and 16 mm you'll push it by using the wet method. Followed?
Yes, sir.
So this distance we have read from this the temperature graph, right?
Yes, sir. Yes, sir. Distance we got it from the temperature graph. Okay. Now, this is there. Okay, you have seen this. Draw a line nearly straight like the connecting records points on the wheels. Extend the straight line for getting actual zero. See here. Extend the straight line for getting actual zero position. Standard point of push-up distance which crosses x-axis in the graph. So what do you understand by here? So it is like you will give some pressure, say 50 bar, and you will adjust the pressure gauge, the dial gauge at 0, because at this point the instrument is set properly. The decreasing of the pressure is not there, and the movement of the propeller is also not there. So it is at the beginning. Now you are at the doorstep. Okay. After that, whatever you increase the pressure, according to that you record the distance also. So for this pressure, the distance is not recorded. So how do you come to know this, the recording for this distance? Now you are looking at the distance, but same time with this distance, understand the friction also. Finding a point? Following everybody?
Yes, sir.
In the similar, like theoretical, if I say the oil pressure, which is overcoming the friction in between the boss and the propeller, that is the point where the pushing starts. I repeat, when I give a pressure, oil pressure, that has to overcome the friction between the boss and the propeller, that time the push-up starts. Now, the oil pressure which I am giving here, that is less than the friction in between the boss and the propeller. That's why the propeller does not move in.
Just about.
Following?
Yes, sir. It's just about to move.
Yes, sir. Okay, sir.
Yes, it's about to move, but has not made any movement. But there is slight increase in the pressure. This pressure does not move it. Why? Because the friction in the boss and the propeller is more than the pressure what you are given. That's why it is not moving any further inside. But you have applied some pressure. That is the point. Okay?
Yes, sir. Understood, sir.
Okay. Next, you understood the instruments also. Now, what is W thing? Let's see what is W. See?
Sir, please explain one thing, sir.
Hanji.
After applying your dry method,
Mhm.
1/5 already push up. Okay, understood.
Uh-huh.
But when you are going to apply wet method, then why there is a drop in pressure? Like you draw na first that you drop little down and then you draw wet line.
Okay.
In graph. Why there is a drop?
Okay.
Friction reducer.
Now this drop is not to be calculated on this graph. The drop is the sense that D pressure is given.
Yes, sir.
Okay. So how much D pressure you are given from here? Let's say 300 bar.
Yes, sir. 300 bar. Okay.
Okay. Now understand the pressure is directly proportional to distance and it is inversely proportional to the W pressure what we give. Okay, that is reduction of the friction between the two. So the dry pressure when you apply 300 bar, you have seen for the dry you need 100.5 tons for 1 mm.
Yes, sir.
So how much is the approx you have moved is 3 mm,
3
right?
mm. Yes, sir.
But now in the actual what you are doing, you are not changing anything. The system is same. You have still applied 300 bar pressure here. The propeller has moved say 3 mm on the shaft. There
Okay,
is
sir.
no change in the distance. Now what I will do, I'll start giving the W pressure here. Okay. Now the coefficient of friction in between these two will start reducing. As and when I start giving the W pressure, what happens? This point will as equivalent that it will drop. Why? Because when I start giving W pressure, the mu starts reducing, the propeller starts moving forward. Now, so on the 32.5 mm tons is required for the 1 mm and to the friction if it is from 0.025, right? So
Okay,
on
sir.
this, it is like we have moved 10 mm. That means when you start giving the W pressure, what happens? The propeller will start moving forward even though you have not applied D pressure. D pressure will start dropping now. Understanding the point?
So when we are giving this W pressure, the valve B will be open. We will open that valve.
Yes, sir. Yes, sir. That will be open and the pressure will start dropping.
सर इसका मतलब जो सर ड्राई मेथड के लिए प्रेशर हमने अप्लाई किया था, वेट प्रेशर के लिए जो हमने अभी ऑयल रिसर्कुलेट किया, जैसे ही मेरा बॉस आगे फॉरवर्ड शिफ्ट हुआ, उसकी वजह से जो ड्राई प्रेशर था वो ड्रॉप हुआ है.
ड्राई प्रेशर नहीं सर, जो अंदर ऑयल का प्रेशर होता है वो ड्रॉप नहीं होता है. ठीक है, आई विल अगेन कंसीडर ए सिलेंडर. In that, let's consider two of the piston. Okay, one piston idhar, one piston idhar hai. Okay, two of the piston, and here there is a hydraulic. Okay, I want you to answer now. Now there is a pressure given from here. Okay, and here there is a restriction. Restrictions in the sense here there is a big box kept, or there is a force which is being applied onto this piston. So this piston is not moving backward. Now you start applying this pressure. So what will happen? Will the pressure gauge start showing more pressure?
Yes, sir.
Okay. Now as long as, see here, there is a friction in between the land and the box. So now what happens? I will start applying oil here. That means what happens? The box will start moving forward. Why? Because there is a reduction in friction, but I haven't increased the pressure here. The oil inside, the pressure in here which is stored here, that is sufficient enough to move this forward.
Yes, sir.
Similarly, udhar bhi ho raha hai, sir. As I apply the friction, as I reduce the friction from 0.131 to 0.025, which is almost 5 times lesser than this, or 6 times lesser than this. So what happens? This will start moving forward. This is the propeller boss will start moving forward and the pressure will start dropping. So it will be an equivalent pressure for the equivalent push-up distance.
सर इसका मतलब जो अभी आपने डायग्राम बनाया है, इसके अकॉर्डिंग जो वेट प्रेशर हम देंगे वो मेरा फ्रिक्शन रिड्यूस करने के लिए है, और जो ऑलरेडी प्रेशर ड्राई फिटिंग का है वो मेरे को पुश करने के लिए है.
Yes sir, yes sir, absolutely.
Okay sir.
समझ गए अभी आप?
Yes sir.
So everybody followed it?
सर एक चीज पूछना था सर, दिस एक्चुअल पुशअप डिस्टेंस
it is the significance. We can say that whenever we remove and fit the propeller, the actual push-up distance will always remain the same in any temperature conditions. That's why we need the standard point.
Yes, sir. Yes, sir. You can say that the actual push-up distance remains the same in any climatical conditions or the temperatures basically we are seeing. But what happens? The theoretical push-up distance changes, but actual push-up distance is what it is significance. The actual push-up distance is nothing but the actual friction that you want to have in between the propeller boss as well as the tail shaft. So the only friction is the reason why the torque from the propeller tail shaft is being transferred to the propeller. Here
Yes, sir. Yes.
We are talking about the push-up distance, we are talking about the pressure, but what is the ultimate point that we want to reach? That is mu.
Friction between the
Friction between
the boss and the shaft.
Yes, sir.
shaft. Yeah.
So followed, everybody?
Okay, sir.
Okay. Now the same thing when you apply it for removal of the piston. Removal of the propeller. So fitting is done. I'll take fitting as done because.
सर एक बार डिस्टेंस बता दीजिए, डिस्टेंस किधर से
हाँ जी?
डिस्टेंस
डिस्टेंस किसका सर?
मतलब कहाँ से कैलकुलेट करेंगे?
कहाँ से कैलकुलेट करना है?
हाँ, शाफ्ट पे किधर से कैलकुलेट करेंगे?
सर कैलकुलेट हम तो वो ग्राफ से करेंगे, वो जो आपको ग्राफ पढ़ाया था हम लोग टेम्परेचर वाला।
शाफ्ट पे कहाँ से मेजर करेंगे? शाफ्ट पे
मेजर ओके, तो ए वाला शाफ्ट है सर। Then we had the propeller like this. Okay, so first at the initial point जहाँ पे हम लोग डायल गेज को 0 डालेंगे, वहां से we will take at this is a say example 20 mm. Then from there again we will have 20 mm. So ये जितना हम लोग push करेंगे, suppose if you push at this point and there is 6 mm remaining, how much you have pushed it? This 20
14
plus 14, so total 34 you have pushed it. समझ गए?
Okay.
So ये example के लिए लिया था मैं 20, but you can take 10, anything like that. But you should know that when we have the reference mark and how much you have moved with respect to that reference mark, and remaining distance, moved distance, you will get it. Okay.
Sir, this wet method में आपने कहा first we have reached to 1/5 of this distance required.
Yes, sir.
Then afterwards we'll apply for this expansion pressure. And then it will automatically reach to that point, or we have to further increase the D pressure also, no?
We have to further increase the D pressure until you reach the push-up distance. So in the example what we spoke our pressure we need to push up is 20 mm, right?
Yes, sir.
According to this, when we increase 50, 100, 150, 200, 250, 300, 350. At 350, we saw that it has moved a distance of 10 mm.
Yes,
but
sir.
remaining 10 mm, we'll have to increase the D pressure to reach at that point, right?
Yes, sir. But is there any procedure like we have to increase gradually the expansion pressure also and then D pressure also?
Sir, gradually means first thing what we as and when you starts giving the W pressure, what happens? The D pressure what you are given, that is sufficient to push the propeller further. That is gradual only. Okay. After that, again you can increase the pressure by 5 MPa as they have given, or you can increase it by 3 MPa. That means 30 bar, 50 bar. With the equal intervals, you have to increase it and wait for the complete pushing of the propeller being done. Okay.
Okay, sir.
टोटल का 1/5 ड्राई मेथड से करेंगे?
हाँ जी सर,
1/5 ड्राई मेथड से फिट करेंगे।
हाँ सर, 1/5 अब तो ड्राई मेथड से करना है और
टोटल
रिमेनिंग
का
4/5 टोटल का सर, टोटल का
ठीक है।
अभी 20 हमको ग्राफ से मिल गया, तो 4 mm विल डू इट बाय ड्राई
मेथड
and rest 16 mm by wet method.
And sir, this the actual push-up distance which we got from this standard point graph, this we will how we will consider this as for the wet method final push-up distance.
सर वेट मेथड हम लोगों को ये पॉइंट से हम लोग जितना भी कर रहे हैं हम लोगों को वेट मेथड आ गया.
Okay, so the final point will never change like this.
It will never change, sir. It will never change.
Okay, sir.
Sir, एक बार वो ग्राफ दिखा दीजिए ना सर, that measuring of your push-up distance.
ये वाला?
No sir, not this one sir, the first one.
First one.
Sir, push-up distance calculate करने वाला.
हाँ. Exactly. Okay. Visible clearly?
सर अभी
है ना सर, ये
प्रोपेलर
K करके एक वैल्यू है ना सर, 25.86 tons, 29 tons and 32 tons sir. Sir, this pressure is between your hub and shaft, right sir?
Yes sir, this is in between the propeller boss or propeller hub and the shaft.
Okay, so then after we will increase little, we'll increase your D pressure, then we'll start moving. The D pressure is not calculated, right sir? We'll start measuring the
you can't calculate it, sir. That is an approx.
Okay sir, okay, understood sir. So how long it is moved, we should start increasing.
Yes sir, same thing.
Sir, we keep increasing wet pressure, correct?
Yes sir, yes. No sir, wet pressure you will keep it at a point, and afterwards for the push-up you need to increase the D pressure, right?
Okay.
अभी सर simple ये box है. I want to move this box towards this is port and starboard. Okay. In between the box and here मैंने क्या कर दिया? I have kept a trolley. By keeping the trolley with wheels, what did I do?
Reduce the friction.
Okay. Now I'll apply the force here. Will it move this side? Or by applying the pressure from downward, that means by putting the bigger wheels, will it move this side? We have to apply the force here, right? To move it this side.
Correct, sir. Correct.
So similarly, what I am doing, I am having a box. I am giving a pressure. That means what I am doing, I am reducing the friction by putting the wheels. Now I'll have to give a D pressure. This is the wheel pressure. Okay, wheel also wet pressure. Okay, W pressure. This is equal to W pressure. W pressure I will increase at some point and I will see whether the oil will start coming out from here slightly. The oil or the wheels are sufficient to take the load. And now what I will do, the D pressure as I give, the box starts moving forward. Same thing here we are doing. Consider this as a boss propeller and you have the tail shaft. When I increase the pressure from the oil here, what happens? Boss slightly expands. The friction between the boss and the tail shaft is nullified now. As I give the pressure from here, the boss starts mounting onto the shaft. And after that, what I will do? Suppose I have given a final pressure of, say, example 600 bar. First thing what I will do, I will remove the W pressure, wait for 15 minutes, and I will remove the D pressure. So when I remove the D pressure, the deflection gauge, what it was reading here, should not now divert. If it diverts, what happens? The boss has been coming back, which we don't want. Understood?
Yes, sir. If we are applying some amount of wet pressure and then it is and after applying this D pressure also it is not further moving, then we will apply more wet pressure, right?
No. That time you will apply more D pressure, right? Wet pressure is already there. You are seeing that oil is coming out from here.
Yes, sir.
Okay, that means there is a gap in between. But why it is not moving further is we have to apply D pressure.
Okay, sir.
Okay.
Sir, after applying wet pressure, we close the valve B, sir.
You close the valve D
and then increase dry pressure for
sir.
that.
अगर D का valve close कर दे हो, D pressure का valve close कर दे हो, तो then how do you increase it? So
He's
valve
saying
has to be kept
W.
open, right?
Saying
He
W.
said B.
A का valve का pressure we have to slowly increase now, sir, for the second graph. So are we
Yes,
shutting
sir.
down the wet
That
pressure
D pressure
valve?
will start increasing.
Yeah,
D pressure will start increasing, no?
yes. So for that we have to shut the valve B, no, sir?
Sir, you can shut the valve B also. And if there is a continue oozing out of the oil from here, so the pressure will start reducing. At that time, again in middle, you have to slightly give the oil, right?
Okay, okay, sir. वो देख के
सर
करना पड़ेगा. Okay,
जो
sir.
ए है वो ड्राई का प्रेशर का और बी वो वेट का प्रेशर.
Yes, sir. Yes, sir. B is for wet, A is for dry.
अच्छा तो दोनों का प्रेशर सेम रहेगा.
अब प्रेशर सेम भी रख सकते हैं and you can what you can do here.
एक ही प्रेशर गेज है ना उधर.
Yes, pressure gauge तो एक ही है, but you can cut this and only monitor this pressure. You can cut this and only monitor this pressure. Possible because these valves may have the pressure reduction valves also possible, right? But monitoring of the pressure, once you give some pressure in the B, close the valve, and then afterwards, whatever the push-up you want, you only increase it from A valve. Okay. Okay, now shall we go for removal of the propeller?
Yes, sir. Yes, sir. Please move
Yes.
on, sir.
Yes, sir.
One person. प्रभाष जी, आपको समझ में आ गया?
Yes, sir.
Okay. Okay, next we will see the removal. Removal is very simple. As we have seen, we are mounting it on the tapered portion. Now, in the normal case, when the ship is running, what is holding the propeller boss on the tail shaft? Friction. Yes or no?
Yes, sir.
This is the propeller boss that is being held on the tail shaft only by friction. And of course, we have a nut here. Nut will keep in place just to hold in place. Okay, but we know the push-up distance. That's why the actual push-up distance will remain same all the other conditions and wherever you are removing it. So that's why suppose the actual push-up distance is 25 what we get. So this 25 plus 2 mm, that much amount we have to loosen this nut while removing. So what do? You will loosen the nut so that the nut moves backward. We'll open the nut moves backward, and nut is here. Okay, so this distance and something will keep some cushions, say wood or something like. Why? Because the propeller, when it loose, it should not come and bang the nut, causing wear and tear. That is why we'll keep some of the cushions here. So we'll take this as cushions. Maybe it will be a wood or any rubber things. Now what I will do, I will keep it a distance of gap in between the propeller boss and the cushion. How much? Total push-up distance, actual push-up distance plus 2 mm I'll keep.
Sir, this 2 mm is fixed for all type of propeller?
This is 2 mm?
Is it fixed for all type of propeller or what?
Yes, sir. Yes, sir. 2 mm is why I will tell the significance of 2 mm. Okay.
Significance is clear, but this value is fixed. I'm asking this one.
It will be fixed only. So you can keep it 2 mm, 1 mm. But again, once you start removing, what happens? It should not come and cause the damage to the nut. And what happens if the force is applied from here? It will be difficult for the nut to open. That's what we do now. We'll first remove the hydraulic oil to zero pressure, and that time after that you are able to rotate the nut. Similar thing here. If the force is there from the propeller boss on the nut you can't remove easily. That is the only thing. Okay. So this 2 mm gap I will keep, and we will start only giving the wet pressure. Only wet pressure. Deep pressure need not to give. Only wet pressure. When you give, what happens? The friction in between this propeller boss and the tail shaft is lost, and that what happens? The tail shaft, the boss will start sliding out, because since it is a tapered portion, it will start sliding out, and the shaft, the propeller boss will come and hit the cushions. The cushions are placed 2 mm apart. That means you have seen that initially 50 bar when you are given, you have seen you adjusted the dial gauge to 0. Now this 2 mm is the one which is ensuring that it is clear from the all the friction that is there on the tail shaft. Understanding? Everything is interrelated here. Once you understand particular point, then it will be easy for you to grasp everything very easily. So understood now?
Sir,
Yes,
when
sir.
we are giving this wet pressure, this boss will slide down by
Yes, sir.
itself.
Both will slide down. Why? It is because it is on the slided portion.
Sir, but initially 1/4 of it was done by dry friction method, sir. So the same distance oil has to be applied.
No, sir. Here, see, dry friction will not come out. Why? Because see, when I reduce the friction, what happens? If this is a ram, I have box here. When I reduce the friction between the ramp and the box, what happens? The box will start coming on because of the inertia of the boss. What happens? It will come out more. There is an inertia for this, right?
Yes, sir.
So when I reduce the friction here, what happens? Will it come to at this point and stop, or it will just start moving it
Okay,
out
oil pressure is still
until
there.
it reaches some
Yeah.
the restriction?
Yes, sir.
Yes or no?
Yes, sir. Until it comes
To
fully
a
down.
restriction. That's the thing, sir. It will start coming out with an inertia. To not to harm the nut, what we kept? We kept the cushion. That means more inertia also will come with a more impact. We have to take care of that impact also. We have to take care that it should not harm the nut also, and we have to take care that it slides out completely, so that it will be easy for us to take it out.
Sir, cushion is kept for this propeller nut also for removal.
Yes, sir. See, why this cushion? Because this should not come and damage this. After the cushion is there, once this boss comes to a halt, remove the cushion. That time you can rotate the nut also very easily. Nut has got holes on it, like the pin you take to rotate the hydraulic nut. Similarly, you have a rod, big rod, which you insert in this, and you have to rotate it, just like how do you turn the generator engine using the rod onto its flywheel. Same thing you can do it here. Okay.
Okay, sir.
Clear removal. In the removal, we are only going to give W pressure, but the care has to be taken that total push-up distance plus 2 mm, you have to create a gap. That means you have to unscrew the nut and keep the cushions so that this will not come and harm the nut.
So this 25 mm you have taken the push-up distance from the standard point, right?
Yes, sir, from standard point.
And 2 mm we are giving for what?
For see, suppose 25 is there, then only 25 when you give it, it will come and halt at some point, and there is some still friction in between this. So these are very heavy particles. You can't just push them out with the hand.
Okay, sir.
Again, in the dry method, what we are doing to remove it? In the dry method, what we are doing to remove it? Even though it was on the tapered portion, there is no oil that is provided to reduce the friction, you will have a strong back created at this point. Strong back is nothing but a strong plate. This is the propeller boss. You are connecting the studs to the propeller boss. And now start jacking with this nut. So as we jack up with this nut, what happens? It starts pulling the boss out of the tail shaft. But in this case, what were there? There were wear and tear. Similar thing, we don't want this wear and tear. That's why the simple thing what we do, we reduce the friction on the tail shaft and the propeller boss, because only the friction, that is the only thing that is holding the propeller boss in place. So when you give some distance and reduce the friction, the propeller boss has to slide down on its own and hit the cushions. Understood? This is clear?
Yes, sir.
Yes, sir.
Okay. Quickly moving to stern tube. In the previous class, I have explained you the stern tube, how this is. One question was by Hanji.
क्रोम लाइनर सिंगल पीस रहता है कि टू पार्ट में रहता है?
कैसा क्या सर?
क्रोम लाइनर सिंगल पीस रहता है कि ये टू पार्ट में रहता है?
Which one, sir?
सर क्रोम लाइनर.
Chrome liner is saying.
Chrome liner. Chrome liner.
Two piece.
Sir, chrome liner single piece.
Sir, forward में भी होता है ना?
Forward में दूसरा होता है sir. Again, that is also chrome liner. Why it is in the forward? Because forward में भी lips है.
Yes, sir.
Chrome liner कैसा दिखता है मैं आपको दिखा दूं.
Sir, this propeller manual, can you put it in app?
It is there, sir. Already put in app.
Okay.
Sir, bearings are in two halves, right?
Bearings are also not in two halves, sir. Bearings are also in single half here. Tube है वो. I'll show you the photos of the bearings also. Okay, so this is how the chrome liner looks like. This is how. Simple. Okay. This is completely one single tube, the bearing of the stern tube bearing.
So the chrome
Sir, one question is asked by Gupta sir, that how many bearings are there in stern tube? So answer will be 1 or 2?
Two, sir, two.
Means forward and aft.
Yeah, bearing halves. Okay, let me explain you about the stern tube. Okay, see here. What is this? This is stern frame. Okay, here is the aft peak. Everything comes here. This is out of the ship. Here all seawater. Okay. Stern frame is like this. Now you will have the bearings. Bearing is now fitted like this. Since we can't insert the big bearing, why? Because there will be wear and tear. If you start trying to push the bearing completely through the tunnel, what happens? The bearings will have the wear and tear, and it may have the stresses, and it will, when the stresses are there, what it will happen? It will crack. Okay, this is one complete bearing. Understand? The complete bearing is complete tube. It has got some holes on it. Okay, and from here we'll push out another set of bearings. Okay, now this length of the bearing, basically it was 2 times the diameter of the turn tube. This will be D. That
D.
means the diameter of the tail is equal to the length of the bearing. Okay, so how does this tubes look like is? It's like a bush, not 2 halves of the bearing. It's a bush only, complete bush. Okay, see here. It's a bush only. It has got some holes here. Okay. See, different sides. It's a bush. What we are doing is we are just pushing the bushes inside it so that you will have the fitting properly. So you can't push it completely in. Why? Because the stresses induced will be more and it may crack. Okay. Through this, the stern tube passes. Of course, there are clearances. Stern tube passes and
stern tube or shaft, sir?
A shaft. Tail shaft passes. Here you on the stern frame, the seal cage is being mounted, bolted onto the stern frame, both sides. Bolted onto the stern frame. Green color thing is the stern frame. Okay. Now here is the chrome liner coming. Okay, black color thing what I draw is the chrome liner. Lip seals, again directional. Then again here. Tail shaft, propeller boss. Okay, chrome liner is getting bolted onto the propeller boss. Okay, seals comes here. Okay, Indrajit Singh had asked a question that why this tail shaft is 1:100. Anybody? Why it is tapered? Okay, now whenever we consider the tail shaft, what it is a cantilever. Cantilever in the sense on one side it has got if it is a just a rod like this, what happens? We have a weight here. So what happens? This is a cantilever. Why? Because it is only supported at one point, other point is free, and we are putting a propeller here, which is like I'm adding a weight at this point. So what will be the nature of the propeller now? Will it be like this, bent slightly? Yes or no?
Yes, sir. Yes, sir.
Okay. Now we have seen the stern tube. If this is the normal nature of the shaft, so how will the shaft be here? It will be like this. Yes or no? I have drawn it a little bit more curve so that you will understand. So this will be the propeller. This will be the nature, right?
Yes, yes.
Okay. At this point, what is there? So in the normal bearings, normal journal bearings, main bearings, there is something we see it as edge loading of the bearing. What is that? If this is the bearing, we have seen the journals may be bent either in this section or in the opposite section. If this is the nature of the journal bending, so what happens? Here there is a edge loading. Here there is a edge loading. To prevent the edge loading of the bearings, what happens? On the bearings, we will have slightly chamfered in nature. But what do you have here? You're understanding the question? Understanding the explanation?
Yes, sir.
If the journal is being bent like this, so there is a edge loading on the bearing here and edge loading on the bearing here. Similar thing, since it is a cantilever, there is a bent in the shaft, and because of that, there is a edge loading taking place at this point of the stern tube bearing. So now what I will do, I'll slightly reduce and make it taper. So what happens? The shaft will now have a bend. Even though if it is bent, since it has got a taper, what happens? One thing, I'm reducing its weight because of making it taper. What happens? When I have the rod fitted at this point, okay, and now I am having a weight, will it bend more or less than the previous?
Less.
Less than the previous. And also when it bends, since it is having a taper and the bearing comes like this in actual condition, so what happens? So the edge loading is reduced or not?
Yes, sir.
So you understood, Indrajit Singh?
Yes, sir.
And one more thing is, see, three reasons. One is we are reducing the weight of the shaft at the end, tail end. Second thing, easy fitting and removal. Third thing, the edge loading is reduced. So answer all the 3 points so that the complete answer for the tapering is includes all these 3 things, advantages of this.
That's why 1:100 taper, right, sir?
1:100 taper. This is the opening end. This is the closing end. That means it will be like this in taper when I take the more slopes. Okay.
सर
हाँ जी
सर वो जो फॉरवर्ड प्रोब लाइनर को रिमूव करने के लिए हम लोग को तो पूरा इंटरमीडिएट शाफ्ट निकालना पड़ेगा
फॉरवर्ड प्रोम लाइनर को
यस सर आप तो क्लियर है सर बट फॉरवर्ड के लिए
फॉरवर्ड प्रोम लाइनर सर यस आपको इंटरमीडिएट शाफ्ट तो निकालना ही पड़ेगा बट व्हाट इज देयर इज अ फॉल्स seal as I told you
false coupling
false flange
false flange
flange okay
true flange and false flange आपको बताया
हाँ जी, ये false flange रहता है. False flange मतलब ये virtual flange है यार, एक flange बस आपने वहाँ पे fit करके रखा है, you can remove it out. So chrome liner is here. Now chrome liner already आपका खराब हो गया and you want to change it, right? That's why you have to remove the chrome liner. What you will
Yes,
do?
sir.
Take out this half flange, pull the chrome liner outside, cut it, cut it. जब आप उसको काट दोगे तो it will become in two halves and you can remove it. But how do you fit the
Okay.
new chrome liner?
We have to remove the intermediate shaft.
Yes, sir. We have to remove the intermediate shaft, insert the chrome line, and this chrome liner is also shrink fit onto the shaft, propeller shaft, tail shaft. So to remove the chrome liner, what you have to do? You have to heat it up and then jack it. Yesterday, as I said, similarly while fitting is also you have to heat the chrome liner and then with the force you have to put it in because it is shrink fit onto the your tail shaft. So any of the sleeve also, even though you might have seen some of the pumps shaft has got a sleeve. So how do you fit the sleeve? You'll have to heat it and then insert it. Same thing you have to do it here also. Okay.
Okay, sir.
Okay. Next, what I want to explain you is about the stern tube. Complete. So what do you see here is the propeller shaft. 1, 2, 3 are the lip seals, 4, 5 and the lip seal which are resting on the forward chrome liner. Here it is the aft chrome liner. There is a oil connection which is going from the tank P to third. That means the tank which is sending the oil in between the number second and the third lip seal. Okay, the again oil comes here. The oil is being in circulation. Now see here there is one more tank which is sending the oil in between the stern tube. This is for the lubrication of the stern tube as well as for the cooling of the stern tube. Okay, stern tube in the sense stern tube bearing, tail shaft. Okay, now this oil is having a separate loop. This oil and this oil both are now in different. This is what we call it as aft seal tank. Aft seal tank. This is the one what we call it as the stern tube tank. And what you see here, one more in the forward
Forward seal tank.
Forward seal tank.
forward seal tank. So there is a forward seal tank, there is a stern tube tank, and there is a aft seal tank.
Top one is the gravity tank, we call it. Na?
Yes, sir,
Yes,
gravity
sir,
tank. Gravity tank. Yes, yes, yes. Okay. Usually,
Sir, they ask this very common question: ki why we recover a gravity tank? Why we don't use the pump?
why we don't need the pump? Okay. So
Specifically, ki why this gravity tank?
why this gravity? Okay, I answer, sir. Okay. When you have the pump, will the discharge pressure of the pump increase or decrease, or will it remain same?
It will increase and decrease.
Increase करेगा.
It will vary, sir. It will vary.
It will
Just repeat. Sir,
it will
just repeat.
you have a pump, the discharge pressure of the pump, will it change or will it remain same? Why? Because these tanks are fixed. Tank is fixed at a distance, say from the aft seal tank, it is having a 3-meter height. Okay, so it is fixed now. So when we have a pump here, the pump will start always giving the same amount of pressure to the stern tube and the stern tube bearings, right? The discharge of a pump will remain same when it has got the same head, same amount of the liquid operating through it. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So discharge
Okay.
will be the same, but it all depends on the amount of resistance at the discharge
Amount of
side.
resistance. That's why, sir, I am keeping the oil same. That means viscosity of the oil is same. The head of the pump or wherever the oil supply has to be there, that is the same. So if things are same, then what happens? It will provide the same amount of pressure every time.
Yes, sir.
Yes or no? Now, what is happening? Here we have seawater. Here we have aft seal tank, and the oil which we are giving here has to be in conjunction with this oil and the seawater outside. Yes. So as and when the draft increases, the seawater pressure increases. As and when the seawater pressure increases, the stern tube pressure should also vary according to the seawater pressure. Yes.
Yes, sir.
So who will vary this pressure? So if you have in the newer system, when there is the supply of air, the air has got a regulation valve. This regulator valve will take the considering of the depth of the stern into the water. That means the depth gauge will control the air pressure that has to be given to the seals. That will come to in the next class. Means as we go to the air seal section. Okay. Now you understood why there is a pump, why there is no pump, because gravity.
Sir, we have two different gravity tank also, no, for low draft and for high draft.
Yeah.
Yes, yes.
So we change
low draft and high draft, because the pressure has to vary according to the draft.
Draft.
If we have pump will start giving us same pressure, which we don't want. And also including a pump is not economical. Why you want to have a pump when it can be done without pump?
Yes, sir.
Sir, can you explain how the oil circulates once more?
Oil circulates. See, whenever, what is the type of lubrication which is forming in between the stern tube and the bearings shaft?
Hydrodynamic.
Hydrodynamic, sir.
Hydrodynamic.
Okay, hydrodynamic, right? So hydrodynamic, what is the pressure of this hydrodynamic pressure which is created here? It is certainly more than the load of the shaft, right? That's why the oil is able to withhold the shaft in place, not touching the stir tubes either side. That means the pressure in the oil is enough to circulate. So whenever the shaft rotates, the hydrodynamic lubrication which is forming, that hydrodynamic pressure is enough to pump this oil back to the gravity tank.
Yes, sir. But in case
That
of
is
the
how
seals,
the oil circulates.
Seals, there is no hydrodynamic lubrication, but how will the oil circulate over there?
In the seal?
Yes, sir.
Okay. So when the shaft rotate, what happens? The chrome liner will also rotate.
Yes, sir.
So when the chrome liner rotates, what happens? What is the property of the oil? Oil which has got a churning action will always be in circulation.
Yes, sir. So there is there are some bars for like stoppers also, which will increase the pressure across.
Yes, sir, that is there. And what happens? What is one major thing of the liquid? Hot liquid will start to rise up, cold liquid will start to come down. That is why your boiler tubes are slightly slant. No boiler you will find directly as horizontal. All the boiler tubes, anything it is like, they are slightly slant. Why? That is the one of thing. The water is self-circulating. The hot water will rise up, cold water will fall down. Same thing here. Okay.
Yes,
sir, once explain this why there is no pump.
That's what, sir. If I keep the pump, what happens? Pump will give us a constant pressure, whereas the changing in the draft, ballast condition and the loaded conditions, we don't want the constant pressure. The pressure has to be regulated by the gravity only, and that pressure has to be taken care with the seawater, in conjunction with the how depth is the propeller immersed. That will be the head of the seawater acting on the seals.
But the gravity tank is fixed at the same height.
Same height, but we have two gravity tanks, no?
Yes, sir. Low gravity, high gravity tank.
One is we use it in the ballast tank, and one we use it in the loaded tank.
Loaded.
Yeah, loaded conditions.
Sir, my last
maximum draft, maximum draft.
Sir, I have sailed only on the ships which had only one gravity tank. I have not seen two.
Okay. If you, in that case, what happens? You have the air seal in it or the grease filled in between the first and second seal. In those conditions, yes, you need not have two of the gravity tanks because the air which is there, that will have a regulation valve which is controlled by the draft gauge, and that air will increase the pressure and decrease the pressure, and that air which will not allow the oil to escape outside. So only air will go out and it will start bubbling out. You had the air guard seal?
Yes, sir.
Yes, sir.
Yeah, that is the thing. We will come to that thing. Here we have air guard seal.
But sir, when we are having only one gravity tank, then why there is no pump? That is my question.
Okay, when you have only one gravity tank, why there is no pump? I also told two of the things are here. One is the economical way.
Yes, sir.
साउंड चला गया क्या सर?
सर का साउंड चला गया।
साउंड चला गया लग रहा है।
सर तो नहीं है।
सर ही चले गए।
भाई कोई कोलकाता से ओरल दे रहा है क्या?
टाइम भी हो गया।
भाई किसी का कोलकाता से ओरल है क्या? हेलो,
मुझे
हाँ भाई ओरल तो है
कोलकाता में।
हाँ कोलकाता में।
और तो अभी स्टार्ट नहीं हुआ है ना?
23rd का तो लिस्ट आ गया मार्केट में।
23rd तक?
23rd वाला ही आया ना, 23rd तक नहीं, वहाँ से स्टार्टिंग होगा।
ओके ओके, वहीं से स्टार्ट।
उनका स्टार्ट हो गया 23rd।
24 तक आया, 24 तक।
ओके
नहीं,
ओके।
23rd को स्टार्ट हुआ।
और दिल्ली एमएमडी का
24 का भी आया।
और नोएडा एमएमडी का किसका है अभी रोल डेट?
मेरा 22 का आया।
17 आया।
22 जिसका रिटर्न है उसका भी रेट आ गया क्या?
हाँ भाई, रिटर्न का पहले है, रिटर्न का 17 आया, फर्स्ट टाइम दे रहा था।
तो सर से रिक्वेस्ट करके ना मेटलर्जी का क्लास कर लो, कम से कम रिटर्न से पहले। काफी लोग का मिस हो जाता है, बहुत इंपॉर्टेंट ओरल के लिए।
नहीं, बट मैंने रिटर्न चेक किया तो मेरा 21 22 का रिटर्न है, लेकिन अभी ओरल डेट आया नहीं है नोएडा एमएमडी से।
भाई मेरा भी रिटर्न है 21 22 3 और ओरल है 17 को।
ओह, ऐसे कैसे?
तुम्हारा पहले आ गया?
फर्स्ट टाइम तो मेरा यार, अभी क्या करूँ?
अरे ऐसा तो नहीं होता था कभी।
ऐसा कभी नहीं हुआ।
मैं सुना नहीं पहले।
अभी हो गया ना।
कहाँ से दे रहे हो? नोएडा से?
नोएडा से अप्लाई किया था।
भाई मेरा आना चाहिए था ना, मेरा
अरे भाई देख लो 27 तो नहीं है।
अरे भाई देख लिया, एडमिट कार्ड आ गया, 3 दिन मिले ओरल के लिए।
मेरा तो अभी तो रिटर्न का भी एडमिट कार्ड नहीं आया है।
मैं रिटर्न की तैयारी कर रहा था भाई 21 से।
मेरा तो रिटर्न का भी एडमिट कार्ड नहीं आया है।
नहीं आएगा तो लेके
क्वेश्चन हो ना, क्वेश्चन आंसर हो, प्लीज मेरे पास डाल दो ताकि मैं पढ़ के चला जाऊं, बस खत्म।
अरे सर जो बता रहे हैं सुन लो, वही काफी।
अरे वो पूछेगा तो काफी है ना।
रिटेन में बिजी होता ना, टाइम नहीं मिलता इसको रिवीजन का।
क्वेश्चंस बस अपडेट करते हो।
अब रिटर्न का तो हुआ नहीं था यार, ओरल की डेट आ गई, क्या करूं अब?
ए संजीव भाई, ये ओरल वाली लिस्ट कहाँ पे लगी है कलकत्ता वाले?
ग्रुप में डाला था किसने? हमारा रिटेन है ना अभी?
नहीं।
17 का किसी का है क्या ओरल? 17 का किसी का ओरल है?
नहीं यार, तुम अकेले हो, देते रहो, लगे रहो।
16 को है भाई, 16 को है
भाई सर आ गए।
Yeah,
Okay, sir.
we were at the why there is no pump in the line and why it is gravity tank. That is, you understood the purpose?
Yes, sir.
Okay. Next.
सर प्रोपेलर ड्रॉप नेक्स्ट क्लास में
We'll
लेंगे क्या?
propeller.
प्रोपेलर ड्रॉप कैसे लेते हैं उसका बता देते हैं प्रोसेस.
So propeller drop कर लिया ना हम लोग ने?
लास्ट क्लास में बता था.
हाँ उस दिन तो बताया था, मैं फिर सुना था तो.
हाँ
सर
नहीं, हम लोग अगर दोबारा दोबारा वही करते रहेंगे तो आगे का आपका ये कवर नहीं होगा सिलेबस.
Sir, I have a
Okay.
question, sir. This how do
हाँ
you
जी.
alignment of tail shaft and crankshaft, sir?
How do you align?
Yes, sir. Alignment of tail shaft and crankshaft.
Okay. Sir, that is done in the ad, as we all know. What happens? They will have the lasers. Okay. There is a laser point which is set at one point to the other, which is running. Now, on this laser point, they will start aligning the shaft. So the shaft which is aligned has to be in this laser point. Okay, we'll have the shaft, we'll have an intermediate shaft, then it comes the main shaft, crankshaft. That is the main shaft, right? Okay. So this is done during the shipbuilding in the engine. First and foremost thing what they'll do, they'll this align. And now there are again different methods in this. One, they will use the laser beam. Second one, they will use the height gauge. Third thing, they will use the strong thread. And the deflection in the shaft, it is like in the slow speed engines, it should be like 0.025 mm. Okay, and the deflection in the high speed engines, it is like 0.020 mm. That is how close they align these shafts. Okay, so did this question was asked in the oral?
Yes, sir. Oral.
Okay.
Sir, actually, somebody asked if only one gravity tank. So why not pump is there, sir?
That's what, sir. We said now.
No, you actually talk is two gravity tank. That's why. But only one gravity tank have a vessel.
Okay, only one gravity tank. The pump which is operating here has to supply. So what if pump goes wrong and there is no oil supply to the stern tube? And why do we need the pump when the purpose of this is being done by the gravity? So why you have to invest extra economical?
Right.
Okay.
Sir, this is the same line that is also giving oil to the bearings, this white line from the gravity tank.
This line, sir?
Yeah.
Yes, sir. This is the one. See, stern tube tank is the one which supplies the oil to the stern tube. Here in this is the only stern tube. This is the bearing. Okay. This is the portion that is being supplied with the oil. Okay.
Yes, sir.
This is the bearing and the stern tube.
We have the oil in between the bearings also, no?
Yeah, this is the bearing here. This and this is the bearing here. They are shown. Short, it is diagrammatic view only. It's not actual view.
Okay.
Okay. This is the bearing.
But, sir, the bearing is in the forward and the aft part, no, sir, as you have explained.
That's what, sir, I'm telling. This is only the diagrammatical form. This is the bearing. What they are referring here is.
Okay, sir. Understood, sir.
Okay. So the oil is coming, entry point, exit point, and it is covering all these parts. Because here there is a chrome liner, here there is a oil seal cage. Okay.
So sir, from the gravity tank, oil will go to the forward and aft both bearing, right?
Yes, sir. Yes, sir. Both bearings, and in between the shaft and the stern tube also same oil is there. Both bearings, this same oil is provided. This aft seal, is in between the second and third seal. The forward seal will be in between the 4 and 5. This is the tank which is for the forward seal.
Okay.
Sir,
Okay.
in this diagram, there should be stern tube blue ball cooler as well, sir.
Stern tube blue ball
coolers.
Do we have stern tube blue ball cooler?
Sir,
Yes,
actually,
sir.
we have
I had air
Yes.
camel
Okay,
air
okay.
seal and I had stern tube blue ball coolers.
Sir, we actually have this seal pump with the fins,
also.
so that air cooling is there. We have the fins on this, just like motor, no? Tank has the fins type structure outside.
Yeah, see, it depends on the amount of oil that is being used in the normal operation. If the amount of oil is restricted, some amount of the oil we are using, so that amount of oil we need to cool it. But if the oil is used is in large in quantity, whereas the part of the oil which is there, that will only take the heat and it will get sufficiently cooled when it is there in the tank. And again, when in the circulation, it gets heated up, cooled up, heated up, cooled end. Okay. So again, the different system has got different technologies. Like you have seen in the turbocharger, there was a sump, and the sump is taken for the lubrication of the bearings here. This sump needs to be cooled. Why? Because the oil quantity is very less here. So for that cooling, then again we have the water casing for the turbocharger. The basic remains same. Then again, there will evolution. Different makers will give different types of advices, and different makers will have got different methods of lubricating it or cooling it. Okay.
Sir, in this shaft alignment, sometimes while taking poker gas reading, we are said that the engine should be number one unit should be in TDC, or the propeller shaft number one blade should be on the top. So, is
Yes,
there any system where when we have to align the crankshaft with the tail shaft before assembling?
There is nothing like that, sir. As I said, if you look from the aft, on the tail shaft you have a marking.
Okay.
On the propeller boss, there is another marking. Both the markings has to coincide. That is the only one rule. Second thing, why do we keep number one unit at the TDC, number two unit at the TDC? There is no such rule that you have to keep number one only at TDC. You have to read the poker gauge. In the poker gauge box, there is the readings are kept permanently. Okay, poker gauge will be here. When you open the box up, here they will sell. The poker gauge reading is taken in between 1, 2, 3. Either if it is written between 1 and 2, you have to insert the poker gauge here. If it is between 2 and 3, you have to place it here. And they will tell that number one unit was TDC. That means you have to turn the engine to number one TDC. At that time, you will have to insert the poker gauge as said in the readings, whether it was taken between 1 and 2 and 2 and 3. That means we are taking at the same point. That means the previous reading what we had, with respect to that reading, we are taking the new reading. That is the only thing. So to take at the same particular point, that means the previously, when you drop the depth gauge, the poker gauge is going and touching where I said?
Stern tube.
Chrome liner.
Chrome liner.
Now it was touching at the same point on the chrome liner. When the next time also, when you take a number one TDC unit at TDC and in between the 2 and 3rd, then now you drop the poker gauge will touch the same point. That means you know that the earlier reading was also taken at the same point. The new reading what you are taking, you are also taking at the same point.
Okay, sir. Okay, sir. So that has nothing to do with tail shaft. Okay, sir.
Nothing to do with the tail shaft, sir.
Okay, sir.
Okay. Chalo, we'll stop here and continue with the air guard in the next class. Okay.
Yes, sir.
Thank you, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
सर
हाँ yes sir.
सर कभी जैकअप टेस्ट के बारे में बता दीजिए कभी कुछ बाद में.
हाँ sir, that will also will cover sir. Jackup test also will
Okay,
cover.
sir. Thank you, sir.